from? What was that?
5 on page 616.
All right. Yeah, good. So this happens, and this happened today, actually. So this is 5, 6, 16. This is section 9.6. That's it, right? Yeah. So the mistake I get is somebody will say, and it sort of relates to, there was this problem on one of the denominators. I'm not picking on anybody, because there are a few people that did this, and they said that it factored like that. Can you see why somebody would think that? And maybe some of you guys are like, I happen to think that.
I'm thinking about the one in the line.
Yeah, so one thing is, if you multiply this, then you get back to where you were. So then it can't possibly be the factored form, right? If you said 18 is 3 times 5, well, 3 times 5 is 15. You're wrong. You don't get back to where you started, right? So the mistake that was made here is when you take something out, what happens when you put it back in? What operation are you actually doing? When you put it back in. If I were to do this, what operation am I doing? Multiplying. Kick ass. So the property is distributive property, but I'm multiplying. So when I take something out, I am doing the opposite. So I am dividing. What is m divided by m? 1. All right. So here, if I take a p plus 2 out, because they both have a p plus 2, what's left is 2p cubed plus 1. And now, if you multiply back in, I get this, yes, and I get this, yes. So that 1 is like a placeholder, is another way to think of it. Either you can think of it mathematically, you divide by it, so of course there's a freaking 1. Or it's just a placeholder so that this has somewhere to go. I don't know why I'm yelling at you. Sorry. We don't know either, right? Is that cool? So I mean, it's the exact same thing on the other problem that you're asking me about, right? Does that make sense though? Is that part of what you had trouble with? Or what's up?
So like the next one is just, because the next one is 2x cubed minus 6x squared plus x minus 3.
Yeah, good. All right, so let's see. So this is in the same section. How would I do this and why? Grouping why? 4 terms. I like it. So never put parentheses in. I don't know why anybody taught that. That's silly. Because if there's a minus here and you put parentheses, you sort of factor the negative out. Everybody dies on the negative. So just say these 2 and these 2. Don't put parentheses in because then you're sort of factoring already. What comes out of these 2? 2x squared. Now watch this. This is cool. This is the way you save yourself. Always take something out when you're doing it. Always take something out. Well, if nothing comes out, you're wrong. Something can always come out. What can always come out of any number? 1. So take a 1 out. Now that looks more like what we're used to, right? And the next step should be relatively easy. Take the x minus 3 out, and what's left? 2x squared plus 1. But now we can kind of see that 1. We see why it's there. So I really could have put a 1 there. And that's why it's there. Why is it there? Because it's there. I love that answer. That's all. Because it's there. That's why it's there. Good, good, good. This is why you desperately have to ask the question the minute something doesn't make sense. Because it has to make sense. It's created to make sense. And the minute you think that I'm doing something different, like you say to yourself, we didn't used to do that, bring it up to me, talk to me, because math cannot change. We can just add new things, like we'll add in imaginary numbers, we'll add in radicals, we'll add stuff in, but PEMDAS can never change, for example, right? Exponents can never suddenly mean something different in our mathematics we're dealing with now. Okay. There are other mathematics, but we won't get into that. All right. So let me see if there was something else to do there. Of course, number 3 with all the m's, it was just a lot to keep track of. And a lot of people didn't realize that m cubed minus 1. 1 is such a weird dude. It's a square, it's a cube, it's a 5th power, it's every damn thing. 1 to the 80th power is 1. So if I see m cubed minus 1, that's mmm and 111. So I can totally do cubes. Is that cool? Alright. Alright, I think that's mostly everything if we good. Okay. So first thing we'll do tomorrow, I'll give those back. And you'll take a few minutes to look it over, ask me questions, and then we'll do the quiz. So for today, last things I want to do. A little leftover dude from earlier. What's that? Yeah, what's wrong with that bottom? What's kind of wrong with the bottom there? It won't factor, right? Guys, ladies, okay. You can't factor it, not with real numbers anyway. So later we'll actually learn how to factor that using complex numbers. Yeah, exactly. Eventually. The other way to think about it is, if I square a real number, what's the smallest it could be? What's the smallest I can get if I square a real number? What's smaller than 1? 0. And what's 0 squared? 0. But that negative 1 squared is 1. You guys with me? So the smallest number I can get after I square a real number is 0. So what's the smallest the bottom can be? 0 plus 9. The smallest it can be is 9. The only way to make this 0 is to get x squared to be negative 9, and I can't do that with real numbers. So is the bottom ever 0? Therefore, are there any x values that I have to throw out? No. There's no x values that will make this 0. Therefore, the domain would be all real numbers, or r with an extra spine, or negative infinity to infinity because we don't skip anything. Right? That's interval notation, just from one infinity to the other. That'll take you a while. And real quick word, why would I never, what's wrong if I write this?
Oh, there's no equal.
Yeah, why can't I put that there?
It's not an equality.
Yeah, why not?
It's not an equality.
It just keeps going on.
I like it. So if you find infinity, you've nirvana, you're there. You're pure energy, like the end of Powder. Anybody ever seen that movie Powder? Where the guy gets struck by lightning and he's just energy. You're there. You transcended. So if you put an include sign, you found infinity. You picked it up. Hey, there's infinity. That's a little neat. So good. I like the way you said it. It's a process. Infinity is a process. It's not a number. It just says, take one, add it, add one, add one. Keep doing that forever. That's one way to talk about infinity. All right. Just and plus, if you draw, same idea. If you do this, then I'm like, okay, what's that? So don't put infinity on a number line because if you can't get to it, then you obviously can't put it on a number line. How do I represent it in a number line? Shade. That represents it. That's a process. Shade. Just keep going that way. Keep going. That's infinity. All right. I like it. Let's see. What else was there? There's something else. Before I forget. Oh, well, sometimes the easier problems give us trouble. For example,
Just cross.
so what would you do here?
Just cross off here.
Yeah. Yeah, I don't have to factor anything because everything's already factored, right? How do I know everything's factored already? Because
You're not back.
there's no pluses and minuses, right? It's all multiplication. So then what can cancel?
550.
Yeah, there's like a 5 goes into 15. How many B's cancel?
4.
So there'll be 4 left up here, good.
1.
And then 1 more, so there'll be 3.
8.
And then 1A, so there'll be 6. So then I get
4.
12, A, 6, B, 3. And anything on the bottom? No. All right, I like it. I like it. So you guys get a little too much into like factor, and then that gets thrown at you, and for some reason you can't change those gears. You're like, what the hell do I do with that? That's actually an easy problem. That's like, oh, thank God, I can just kill things already. So, now watch this. This is interesting. Let's just do this. I almost put this problem on that group work, but I decided not to.
Now you can find the LCD. Just 6 plus 1. Only for the second.
So here's the mistake. Or is there a different way to do it? Who's got a suggestion?
Multiply the second part by -1.
X plus 1.
Multiply this by -1?
Multiply x plus 1.
Or add.
All right, all right,
You just multiply one side by x and the other side by x.
all right. That's the correct answer. The mistake, and I'm not trying to make you feel bad, I just want you to realize whatever you're allowed to do with numbers, you're also allowed to do variables, which means whatever you're not allowed to do with the numbers, you can't do with the variables. Too damn bad. So you don't say to yourself, oh, he's got an x, so he's missing a +1. No, this guy does not have an x. I want you to really understand what I just said and realize that it's not just me off my meds. And you're all like, there's an x. No, what does this guy have? He has an x plus 1. That's what he's got. He's got nothing else. He's got an x plus 1. Does he have an x? No, he doesn't. All right. Another way to look at this is if you think you can just add 1 to the top and bottom, then that means that 3/4 equals 4/5. Right? If I can add 1 here, then I can add 1 anywhere because this is just a number. I can do it everywhere. You with me? So then 0 equals 1/2. So you owe me $0 million, right? That equals, you owe me $500,000. Give me. You guys understand? So what's the only thing you can do? We know this. But the minute variables come in, you think things change. But that's what I said earlier. The minute you think things change, you're wrong. Come see me. Bring it up. Things cannot change. What's the only thing I can do to top and bottom? I can multiply or divide. That's it. That's all I can do. He's got an x plus 1. He's got an x, so he's missing x plus 1. He's missing x. Right, exactly the same as, how would you do this? 3/4 plus 2/3. How would you add those? What would you do? He needs a 3, right?
Yes.
And he needs a 4? Right? You wouldn't add 1 to the top and bottom. But do you see how it's the same problem? 4 and 3, so 1 more than this guy, they're exactly the same problem. So if x is 3, x plus 1 is 4, they're not the same number, they need each other. Oh. So then this would be 3x plus 2x plus 2 over x times x plus 1. Done. Cool. I like it. It's a really simple mistake to make, and I don't want to make you feel bad if you thought that was okay to do. It's just that you got to understand that you can't suddenly change all math just because you start putting x's in. X is a number that I don't know. It has to act like any other number would. We just don't think that's true. But it has to be true. All right. Okay. So what about, let's see, what was the last thing? What time we got? Oh, cool. We're going to get out early again. Maybe you get a little used to it. There were a couple things. All right. So we've officially made it into 7.4. Oh, here. Exactly. This is what I keep forgetting. All right. I've done 1 so many times. Let's do 2 here.
Yeah, here you can make -1.
So that's what somebody was talking about. Okay. So here, you wouldn't give this guy a 2 minus x and this guy an x minus 2 because you could factor this, right? Or you could just realize if you multiply top and bottom by -1, these become the same. Now, the minute you learn that, you start to try to make more than you can the same. But you notice how here the x is positive, here it's negative. Here the 2 is negative, here it's positive. That's the only time that this will work. They have to be exact opposites of each other. So if you multiply this by -1, the top and bottom, that is legal all day long, right? Because they multiply by 1. They multiply top and bottom by the same thing. So I get 3 over x minus 2 plus -5 over x minus 2. So now they have the same denominator. So then you get -2 over x minus 2. And then what can you do? It's good. Circle. I like it. I was trying to trap you. Too smart for that. It's entrapment. I know. But I'm the judge. All right. Oh, and so this sort of thing happens here too, and this is where things get a little bit weird. There we go. That's not even what I mean, is it? No, it's not what you mean, Jeff. Get it together. Now, one thing I like about this problem is people get a little confused. That bottom is not out of order or something. The cubes don't care where the variable is. All it cares is that there's 3 of everything. Right? So this is 2, 2, 2, XXX. So in the middle and the little dude goes, careful, 2 minus x. Now see, so order completely matters here. The 8 has to end up being positive. The x cubed will end up being negative. If you put it the wrong way around in there, you've changed your problem. You have a different problem, right? And then now, so the numbers go first and the variables go second. Is that really different? No, it's the same damn thing. So cubes don't care where the variable is. Wherever it is, that's where you put it in your answer. So what goes here? Good. The other 2 2's. Plus 2x? No. Always positive. Plus x squared. Why is that one always positive? Because this one already has the sign it wants. If I made that negative, then it would come up positive. Shit. It's supposed to be negative. So that's why the last sign is always positive, because the middle dude sign sets that sign. What can I do now? Yeah, if you take a -1 out, and then these go away. If you take a -1 out of the top or out of the bottom, it doesn't matter. And then what's your answer? Good, -1 over, and you can put that in order. So just be careful about stuff that are only offset by a factor of a negative. Right, so you don't even really have to show too much work. If I see cx minus ax over x minus 6, what is that? You can do it. What's x minus 6 divided by x minus 6? 1. So what's 6 minus x divided by x minus 6? Negative 1. Done. Yay. Something divided by its opposite will be negative 1. Does that make sense? If you don't like that, you can do like we just did. Factor negative 1 out, and you can see it. Negative 1 comes out. X minus 6 is canceled. Answer is negative 1. Kick ass. So just a little preview of where we're headed. What did I give in this? Yes, good. 7.5 is where we handle fractions that are inside of fractions. Oh, yes. Russian nesting fractions, right? Russian nesting dolls? No? You don't like those things? No? You're all like, I don't know what you're talking about, Jeff. 7.6 is where we do this kind of stuff, but we do it's in an equation. So we're going to have rational functions inside of equations that we have to solve. Oh, yeah. And then, of course, 7.7 is what you've been waiting for. It's word problems. Yes, I know. Awesome. All right, so tomorrow, first thing is I give you back this group work. We'll do the quiz. We'll do a little discussion. Then we'll probably take a field trip. Be part of our break. Then we'll finish chapter 7 tomorrow. Okay. Yeah, basically. Yeah, quizzes are very nuts and bolts. There's no conceptual questions. It's just factors to solve. Yeah.
I have a question about the differences.
Oh yeah. Okay. That's why I asked.
I just looked at it right now.
Okay.
I realized I didn't answer it.
Oh yeah, I did that one. I don't think I did it right.
Yeah,
There's two ways you can do this from the beginning because this is weird. I can cut both of these in half, so it's a squares, but I can also cut both of these in thirds, so it's a cubes. The way you have to do it so that you'd actually get it done all the way is you have to start with it being squares. So that means you would cut everything in half. So what would you get there? Right?
Yeah.
Opposite signs. And now each of these are cubes.
yeah.
Little dude, big dude, little dude, big dude. If you start with this being cubes, you can't go all the way. It's weird. It's really... Do you understand what I just did? So you have an option, and the correct option is to start like it's a squares, and then you got two cubes. So do this problem, little dude, big dude.
Then that one stays because it's positive.
No. Cubes can handle sums. The reason is,
Oh, I guess
I can't solve this with a real number, right?
Right.
I can't have x squared equal negative 9.
Right.
But I can have x cubed equal negative 8.
Yeah.
So that means x cubed plus 8 should be factorable. So I can factor sums of cubes. I just can't factor sums of squares because squares are less flexible. They can only come out positive. Right.
So once you do big dude, little dude for both those, that's the answer.
Then you're done.
Okay.
Yeah, because the big dude won't go anywhere.
Uh-huh.
Yeah.
Okay, thank you.
Sure. Oh, I'm going to email it when I get back to my house. I'll just email it to the whole class. Yeah.
I have a question on number 6. I wasn't sure.
Oh, yeah. Well, what do you do first here?
You would multiply the negative 6. Positive, you're going to have positive 3,
Good.
negative 2.
There you go. So it'll work. So then you split up the middle term. It just looks like it won't work.
Every third one we just jump right
No, so multiples of 3 is 9, 12, 15. Sure. Cool.
I'll shoot you an email.
First home.
On Thursday, I'm not gonna be here with my sister.
Okay.
I'll just email you.
Good, because Thursday I'll be giving out the practice test. And on Monday I'll have the answer key for it, so.
So should I come tomorrow?